Okay guys, I want to start with 10.5 in this video. There's not a lot to section 10.5, so I actually have already written through these notes and posted these on Blackboard. I'm going to talk through them here because that's a little bit easier to do. The main thing in 10.5 you need to know is that you cannot leave any radicals in a denominator of a fraction. So that's what it says, like right up here. The process that we go through in order to remove radicals from the denominator is called rationalizing the denominator. So in order to rationalize and remove the radical from the denominator, you have to multiply by whatever radical that you see in the denominator. So in this problem, I had 9 over the square root of 3a. This is the part that's not good. I can't leave that in the bottom. So that's my radical, so that's what I multiply by. I have to multiply on top and on bottom by whatever I see, whatever the radical is. Okay? So when we do that, we have 9 times radical 3a. That gives me 9 square root of 3a. Okay? On the bottom, we have the square root of 3a times the square root of 3a, and we've learned in section 10.4 that that means that I'm just going to have regular 3a. A radical times the exact same radical, exact same type of root, they're both square roots, is going to give me just 3a. Okay? You can see that I can simplify further here with anything outside of the radical. So that's why I simplified and divided by 3. 3 goes into 3 once, 3 goes into 9 3 times. So this is my final answer. Okay? The next problem, the only radical that's in this denominator is square root of 3. The 2 is okay, it's a whole number. It's just the radical part that shouldn't be there. So I'm going to multiply by the square root of 3. Whatever it is, I'm going to multiply by it on top and bottom. So then on the top, I can multiply the 2 and the 3 because they're both underneath the square root. Same type of root. So 2 times 3 is 6. 5 times imaginary 1. The square root of 3 times the square root of 3 is just going to be 3. Because isn't that square root of 9? And we know that's 3. So 2 times 3 is 6. Well, sometimes you have a little bit more involved in your question. So, as usual, once you have addition or subtraction in a problem, it changes things sometimes. Like we can't cancel as much. We have to think about it a little bit more complex. So 2 minus the square root of 7. It's not just the square root of 7. It's more than that. So I can't just multiply by square root of 7. I actually have to multiply by what's called the conjugate. The conjugate is when you take a binomial, right? This is a binomial. I could put parentheses around it if I wanted to. When you take a binomial and change the sign in the middle. Okay? That's what it means when we take the conjugate. Change the sign in the middle. But then we multiply by it. So you can see that that's going to be the other form of multiplication that we learned in 10.4. So on the top, this is just going to be distribution. 6 times 2 is 12. 6 times the square root of 7 is 6 square root of 7. Down here, it's 2 different binomials, different signs, but they're binomials. So this is going to be FOIL, just like you learned in 10.5 and 10.4. So 2 times 2 is 4. 2 times the square root of 7 is 2 square root of 7. Negative square root of 7 times 2, that's negative 2 square root of 7. Negative square root of 7 times square root of 7 is just going to be negative 7 because we know it's the square root of 49. Because you changed the sign, that's the most important part. Whenever you change the sign, it created this ability for there to be opposites to cancel. So it's very important that you remember to change that sign. 4 minus 7 is negative 3. And only because each of these numbers have something in common on the outside, not what's under the radical, but all of these other 3 numbers have something in common. That's the only reason I can simplify further. 3 goes into 3 once, 3 goes into 12 4 times, and into 6 2 times. This is a negative though, so it's going to change both of those signs. Negative 1. Okay? So this would be our answer, negative 4 minus 2 radical, or 2 square root of 7. So anytime you have addition or subtraction present in the denominator with a radical or square root, you've got to change the sign. So if it had been positive here, I would change it to a negative. They always have to be the opposite sign when you apply the conjugate. I also included, because see, everything on this page is square roots. And that's the majority of what you deal with when we rationalize is square roots. I did include an example for you of a cube root. You're probably not going to see this on the test, but it does come up in the lab. And you're really going to have to understand this part in order to do cube root rationalization, because with the square root you just need pairs of 2, right? Well, with a cube root you need pairs of 3, remember? So if this is my original problem, 4 over the cube root of 3, if all I did was multiply by one more of these, that would be the cube root of 9, right? 3 times 3 is 9, and 9 doesn't have a cube root. I have to create a perfect cube number in order to be able to drop the radical. So with a cube root, I need 3 of the same number. So I need to actually multiply by whatever's under the radical 2 times. So that now I have 1, 2, 3 3s. So that this can actually become a whole number on the bottom without a radical. On the top, it's going to be a little different because I have a 4 here, and then these are just 2 3s. So that's why I have 4 cube root of 9 over 3 would be the answer. So check this out. Like I said, this is just for a cube root problem with a radical in the denominator. And it does show you that you could have multiplied, instead of writing it out 2 times here, you could have jumped straight to, oh, I need 2 more 3s, and you could have multiplied by this. Because we know that this is a 3 and this is a 3, and then there would be your 3 3s. So this is just an alternate approach. Okay, so I did include this in the notes. All right, well, I'll be back soon for 10-6.